Congratulations! We survived the first day of Physics 102X. I'm going to go over a few things here that are in the forums, but I think there might be a lot of students that don't read the forum, so I want to make sure everybody is caught up on everything. First, if you're a student who downloads the videos because you don't have YouTube, I want to let you know that the transcript files yesterday were not working. So if you downloaded them on October 7th and they didn't work, don't worry, they work today. I changed them to SRT files and those work with all the standard media players. So if you re-download those transcripts today, they should work just fine. Also, I made a text file of the transcripts that you could look at. There's a link under the board image of each lecture. So if that helps you, you can look at those. Also, from students downloading the videos, there's been already a request for smaller video sizes. 300 megabytes kind of takes a while to download, I understand. We don't want to lower the resolution because you got to really be able to see the board. That's kind of the whole idea. So we don't want to do that, but we have found a way to get them down to about 60 megabytes. So as long as the download, lower than 100 megabytes is okay, then that should be okay. So let me know if that goes all right. Those should be up sometime tonight. I would have had them up earlier, but this morning I'd cleared my schedule because I kind of thought the Nobel thing was going to happen. I got overlooked again. So anyway, by the end of tonight we should have the smaller videos up. There have been some homework questions in the forums, and you guys have done a good job of answering them with each other. So I haven't really jumped in on those because that's what the whole idea is. You're supposed to help each other and it helps you learn the material. So that seems to be going well so far. And then there were 2 problems found in the lectures, which I was shocked over because I'd gone over these so carefully. But once you go over something too much, you really can't evaluate it anymore. One of them was simply in the very first video, I said electron instead of proton once. And I think most of you got it from the context. I was making a table and you knew what I meant. But just to make sure that there's nothing wrong in the lecture, I went and redubbed the audio last night for that one little part. And it kind of sounds hilariously bad if you want to go listen again. But anyway, it does say the proton now, so it should be all right. The other one was within an hour of the forum opening. The forum opened, everybody's saying hi, everything's fine. Within an hour, someone points out that they think I calculated a tangent of an angle wrong. So I almost had a heart attack. It took me a while to calm down to see what had happened. I couldn't imagine I'd done a whole problem wrong. And it wasn't that bad. It was actually this problem where we have 4 charges and we're calculating the force on charge 1. And we did the whole thing and we did it all correctly. And in the end, we had the force in vector components. But then I pointed out you might be asked to give the magnitude and the angle. So then I didn't do it. So let's actually do it. So the magnitude of F1 would just be the square root of 2 components, 4.78 squared plus minus 40.57 squared. And if you put that in your calculator, that's 40.9 newtons. So that's how you get the magnitude, or just the length of the vector. And then the angle. And this is where I went astray. I was seduced by my own beautiful drawing. We had this nice line here. We had a nice little vector there, which actually I think we had labeled as the unit vector 3,1. We went to all this trouble to calculate that it was at 14 degrees. And I thought about the angle and I looked at that and said, and then the force is at 14 degrees. And of course it isn't. F3,1 would be at 14 degrees. That's why we calculated it. F1 is the sum of all those forces. So of course it's at a different angle. So let's go ahead and just calculate it and think about it just to make sure it's clear how to do it. If you wanted to think about it in terms of vectors, just do the vector addition in our heads, sort of. We could draw F3,1. It might be kind of like that, along that line we just drew. F2,1 will be a little bit bigger because charge 2 is a little bit closer. Okay, this might be something like that. F2,1. And then F4,1 will be down. It'll be actually very big. I'm not drawing this to scale, but this is 4 times closer than this. So the force is 16 times bigger. So way down here, F4,1. Like that. So if you imagine adding those in your head, keeping in mind this one's actually much longer, then it'll be a vector kind of like that. F1. So we expect the total force to be a pretty large angle from the x-axis getting pretty close to the y-axis pointing down. If we want to figure out that angle, we just draw it here. So this is now the angle we want. We have a right triangle here, like that. And we know the 2 components of this triangle. This is the x component minus 4.78. This is the y component minus 50.57. So theta would be the inverse tangent of opposite over adjacent. So opposite is the y component minus 40.57. Adjacent is the x component minus 4.78. calculator, and you get, yeah, 83 degrees. Oops. So just like our drawing suggested, it's a pretty large angle, getting pretty close to 90. All right, I'll see you soon.